Okay. Redox reactions, or redox.
Redox reactions, or reduction and oxidation.
Oh, that makes sense.
These are those
I was gonna
reactions
say,
we were talking about on the last slide.
I was thinking when I saw that, I've never seen a red ox.
No.
I've never seen an ox in general.
I've heard of a blue ox. I haven't seen him personally, though.
Babe.
Yep.
Babe.
His name's Babe.
Not the pig.
Nope. Paul Bunyan's Babe. Ox. Moving on. All right. It's a combination of oxidation and reduction. So let's get some definitions for those things. Because the last slide, or the last lesson, you just learned about the numbers. How do you assign oxidation numbers? Well, it turns out there's a point to that. Who knew? It's to get these definitions down. Because something happens in a chemical reaction when things change places. This is how they get oxidized and reduced. Oxidation is defined as something losing electrons.
So when we lose electrons, remember, we're actually getting more positive.
You're losing a negative charge, it gets more positive. That sounds confusing. You're losing it, but it's becoming positive. It's going up.
Yes.
The charge goes up.
We're losing negativity.
Losing electrons, the oxidation number is going to go up.
It's like when you lose your bad attitude, you become a more positive person.
I love it.
Yeah.
I've never heard that before.
Me neither.
Because you're just, brilliance just flows out of us.
That's right.
Reduction is the opposite. You gain electrons, and since electrons are negative, it's going to get more negative.
So you're reducing, but you're gaining something.
Okay. Yeah.
Pay attention to the definitions, because they're not as straightforward as it would seem.
They're these are really easy to confuse. So it looks like oxidation loses electrons and reduction gains electrons. Well, it turns out these always happen together because the electron moves from one substance to another.
So they're like partners.
They're like partners in chemistry.
Yeah.
Partners in chemistry. And it turns out since the substance that's oxidized is giving electrons to the other one, we can say that it is responsible for reducing the other one.
So
if you weren't confused yet, the substance that is oxidized is also called the reducing agent.
because it brings about the reduction in the other one.
It is reducing the other one.
I was doing some awesome hand movements there too, but you probably couldn't see them.
I wish you could have. Conversely, the reduction substance is taking electrons, so it's responsible for the oxidation substance getting more positive. And it's called the oxidizing agent. It is reduced, and it is oxidizing the other thing.
So it's bringing about the oxidation
Yeah.
of the other substance.
They're like 00 agents. They're responsible for I don't know where I was going with that, but
Okay.
they're agents.
Me neither.
Just know that the agents are opposite of the definitions. Oxidized is the reducing agent. Reduction is called the oxidizing agent. All right. We've got a cute little way for you to remember that. The first one is a mnemonic device called oil rig. This is literally taught all over the world. Oil rig.
So O, oxidation.
Oxidation
I is L, loss.
is, I don't know why I put two I's in there. I didn't do it for anything else, but oxidation is loss of electrons. Oxidation loses electrons, becomes more positive, loses electrons.
And then reduction, it is
Gaining electrons. Oil rig. Now that one is very useful. My personal favorite is a little cuter than that. It's if you know that your constellations, Leo the lion, well, he goes grr.
This is my favorite too.
Yeah.
This is what I was taught in college. chemistry.
Right now I have hand motions up too because it's grr. Just picture claws coming. Grr. Okay.
Oh.
Leo the lion goes grr. Same definitions. Loss of electrons, oxidation. Gaining electrons, reduction. I did it with electrons too. Electrons. But just remember those two devices and that'll help you define them. So what are we going to do here? How do these definitions come into play? Well, you're going to have a reaction. And this is the last slide you had. Except for these two steps at the bottom. First thing we're going to do, we're going to assign oxidation states to every element in the reaction.
Every element in
All
the
of them.
reaction.
All of them.
Every single one.
And then we're going to look at how the element changes from the reactant side to the product side, because it's going to be on there twice.
Yeah, and then we can judge, is that element getting more positive?
Or more negative. is it being oxidized or reduced?
Yes.
So here's an example. Hey, look, there's a random word on the screen. Ignore
Reducing agent.
Ignore the word behind the curtain. We've got a couple of elements up there. So the first thing we need to do is assign oxidation states.
So potassium.
Potassium and chlorine,
Element.
those are both elements. They're
Alright.
0. We're
Alright.
going to go through this assuming you know how to do oxidation states to save some time. Don't you love us for saving you time? Hey, by the way, okay, just kidding. Real saving time. This is an ionic compound, KCl, charges +1, -1. Those are their oxidation
Hey,
states.
it looks like the coefficients don't matter in this particular stuff here.
No, they don't.
Oh,
You're
that's
just
kinda nice.
You're really just looking at each thing by itself.
That makes things a little simpler.
Yeah, ignore the coefficients. So, what's going on here? Well, it turns out that the potassium is changing.
It's going from 0 to +1. It's getting more positive.
More positive, which means it lost electrons and it's oxidized. Okay? It is also the reducing agent. It is both. The chlorine, on the other hand, is becoming more negative.
So it's being reduced,
Yep.
which means that it is also the oxidizing agent.
Oxidizing agent. Now, here's something that is a little different. We're talking about the reactants. So we say the whole chlorine, the Cl2, changes into Cl. The Cl2, the molecule, is reduced. It is also the oxidizing agent. So if questions come up, what is the oxidized or reducing agent, or what is oxidized and what is reduced, you're looking at the reactant side. Which of those substances starts the change? Potassium, chlorine. Here's another example. Just random things stay off my screen. All right. Assigning oxidation states. Let's do the easy ones first. Those are the ones we have rules for. Hydrogen is 1, element 0, oxygen -2. But then the carbons are a little different.
So we have 4 hydrogens in there.
So +4,
+4 for the carbon.
that one's -4.
-4.
On the other side, oxygen's -2, there's 2 of them. So I've got +4 now.
Ooh,
Ah, okay.
like a 180.
So what's oxidized? Which one is getting more positive by losing electrons? It turns out it's the carbon. So, since the carbon is in the CH4 on the reactant side, the CH4 is oxidized, that molecule, because the carbon changes states. And it's reduced is the oxygen, because it's going, that arrow is already there. You cheated. My fault. It goes from 0 to -2.
So it's gaining electrons,
Gaining electrons.
becoming more negative.
Reduced.
Reduced.
CH4 is my reducing agent, and O2 is my oxidizing agent. Let's try one more. Oxidation states. On the left, we've got 2 elements. Those are 0.
Zeros, all right. Ionic compound on the right, so it's just our charges.
Normal charges. Looks good. Looks like all of this slide should come up in order as we planned it.
Nice.
Oxidized. 0 to
Aluminum
3.
became more positive. It lost electrons.
That's
It
oxidized.
leoed.
Leoed. Loss of electrons. Oxidation.
Yeah.
And reduced was the oxygen. It went from 0 to -2.
And the oxygen GERD.
It GERD. The oxygen GERD. That's funny. Aluminum
So the
is our reducing agent.
And then the oxygen is the oxidizing agent.
And really all of this means is you're just kind of, remember the whole point of this is they're transferring electrons in order to react. The aluminum gives off electrons and the oxygen takes them in. So they're transferring electrons to one another. That's what a reduction or a redox reaction is, and how the Statue of Liberty turned green, for instance. Or your car rusts. Any other examples? I can't think of any.
I'm done.
Any metal rusting.
Heavy metal.
Like Metallica would be
Yeah.
reduction. Bon Jovi?
Yeah.
Probably not. Maybe old Bon Jovi.